This is the second time I'm making this video because the first time it was just a little bit too long. It was like 22 minutes and it doesn't need to be for what I'm trying to show. And what I am trying to show is how you can get transactions using the Akahu API. So Akahu has this transactions endpoint that you can use if you have access to this API in New Zealand. And it's really powerful, it's really easy, it features some data enrichment, which I really like, but I'm not going to be showing in this video. And I thought I'd just sort of dive in and just show you just a quick, it's not too long, the program I've written for how I process this in Swift. And please forgive me if my vision's not all that great, so I might just be sort of way closer than I need to be. You'll probably see that in the camera. But starting out, we import the foundation and the playground support library. Those are just required so we can access types like decodable, identifiable, and our playground support is needed so that we can run code like our asynchronous API calls without needing to, which are indefinite. Sorry, so we don't know how long they're going to take, and Swift, these playgrounds will crash if we don't add in the support and call a function later. I can't remember what it was called, but it's at the end of the code. It's at the end of the program. So I first define my secret keys here. So this is my user token and my app token, which is required to get to the Akahu API. If you want to take a look, I suppose we can. Or maybe not, maybe next time. I've actually got my secret keys defined at the bottom of the code, and they're also hidden. So you're going to have to try a little bit harder to get my API keys and get access to my bank account. So moving on, we have this structure here, get all transaction responses, and it conforms to the decodable type, and that's required for when we want to map our JSON data that we get back from the API to what our Swift model looks like. It just follows the same structure as what is defined by the Akahu API. When we make a GET request to the transactions endpoint, and we specify our query parameters and we provide the right headers, our response features a success key and a true or false value. We have an array of items, which are our transactions, and at the very bottom we have a cursor, which is required for the pagination, which I'll discuss a little bit more as we go on. So all these structures here, from get all transaction responses, this transaction structure, we have a merchant, a category, T category in this case, because there's another category structure I use in a different program, and I've just copied from that program. So all of those structures are used just so that we can create models for how we want to represent our JSON data in Swift after we've fetched it, and we need to decode it and sort of store it in our Swift playground in this instance. Okay, so this fetch transaction data function that I've created is sort of like the meat and the chips, I suppose, of what I'm wanting to show you. It accepts a user token as a string and an app token, which I am not going to share. That would be that could go really poorly if I did. It's an asynchronous function, and it's going to return an array of transactions, which is the transactions that I've made, like my purchases or transfers between bank accounts that I might want to see if I'm doing a monthly budget, for example. And it's asynchronous because we don't know how long this API call is going to take, so we need to make sure that this part of the code is not going to block any other parts. If we're running a Swift UI application, for example, we still want to be able to render different elements while this code is being called and sort of not have the whole interface freeze up. So what I do is I create an empty array of transactions. This is just stored locally within the function, and a variable c, which is our local cursor. I create an array of query items, one that features just a fixed start date in the ISO 8601 format, I think. I'll look it up. 8601 formatted date. And so I've just pasted that in as a string, a start and an end date, and that's the time frame, I think it's about a month, where I want to get my transactions over. And in the other application I'm working on, Taku it is something that the user can define or specify. So if you want to see some updates for that, the Taku Rawa repo that I have created, it's publicly available on GitHub. It's use at your own risk, because it's code I'm developing and I'm still learning, to be really honest. But it's something I'm going to submit to the Swift Student Challenge for next year, which is why I'm starting now. So I've got a bit of time to work on it and sort of test it and trial it, make some videos explaining how it works as well. And after the Swift Student Challenge, I'd like to sort of do something a little bit more with it. I'm not sure what yet. Maybe open it up to contribution from a wider community. Once we've done this, I'm going to try and be a little bit more concise with this. I have this while true loop that we enter, and this is a really bad idea. Because you can create sort of infinite calls if things go wrong. So you should have some sort of exit condition that a while true loop can make. But this is the first thing that I wrote, and it worked. And this is what I'm going to show. But I do encourage you maybe just to think about how you can improve it yourself if this is something you want to include within your own Swift application. The first thing we do is create a URL to the transactions endpoint. I create a copy of the query items or the query parameters, and if our cursor is not null, so if there is a cursor that can point to another block or page of transactions that we can access, then we want to append those to our query items as well, the copy of our query items. Then we append that to the URL which we defined it here. So that's just added in our query parameters to our URL. We create a request and add our authorization, our user token, and our app token as well. Then we make the request and we get our response in the two variables data and response. This is where the asynchronous function call is made. So we make our API call to the endpoint, and we wait for the response, and we wait for the data that we get back as well. What I do here is just check whether or not the response was a success, and if it wasn't, we'll just throw an error and we'll just exit out of this function. And if it was successful, we want to try and decode it. So we have this JSON decoder, decoder, however you want to say it, and we pass in the model structure that we want to decode it to, and we pass in the data that we have been given. So we will get data that's structured very similarly. I think the only coding key that I use, or where you change the name of one of the JSON data keys to match your Swift model or structure, was just for the ID, because the response, I just use the ID from the JSON response, which has an underscore in front of the name, so it can't directly match without me explicitly stating how I want that to match. So underscore ID equals ID or something. It was up in the showing up in the program above, but it's not too important. Then append only the items of that, which is our transaction, so an array of transactions. I'm using the contents of argument parameter because I'm passing this in as a parameter because we have an array of items. We don't want to just append one item to an array. We want to add a whole bunch of items, which is an array in itself, to an existing array. So we use contents of here, and that's just explained in the documentation that I was reading. You can even find it if you type in transactions.append. You've got new element, you've got contents of, so one is for a single item and one is for contents of, and I'm just going to get rid of that quickly. It's going to restart the program and it's going to kind of spoil what actually happens, but let's not worry about that. We'll get there. Once we've done that, we then check whether or not the cursor sort of object that we got back from the API is null or nil or not. And if it is nil, then it means there are no more pages of transactions that we need to get. We can exit the program. So if it is not nil, then it means that there's more transactions that we need to get. So if it's not nil, we set our local cursor to the value of that cursor. We know it's not nil, so we can force unwrap it here. And then we repeat this process with the only difference being this added if statement here, where we just update the query parameter to include our cursor value as well. Once that's made, our cursor then points to the next page of transactions, so we don't get any duplicates, and so that's why we're still appending data to our local transactions array. Once that's happened and you've maybe made 2 requests because you've got somewhere between 200 and 300 transactions you want to get between a specified time frame, then your cursor then the cursor that is received from the API is going to be null, which we check whether or not it's nil here. That's how we know we've finished getting our transactions. We've already appended the last of them here, so we can return our array of transactions here. This here actually does contain my secret, my app token and my user token, so I'm not going to share those. Down here we create a variable all account transactions. That's what we save. That's where our returned array of transactions from our function call is going to get saved to, and you can see that down here when we do our when we make our do catch statement. So we use try in case an error is thrown, which we have 2 spots where errors could be thrown here, whether or not we have a bad URL or if we get a response, an error code from the server. And then we specify that this is an asynchronous function call. We use await to denote that, and that just means that we don't want this to be a blocking bit of code, and we also don't know how long it's going to take to execute because we don't know how long that API call is going to take. I pass in my user token and my app token to the function call. Sort of we print any data, any errors that we might get, and then I just print out the total number of transactions that I have here. This playground page.current.finished execution, that's required if we don't have like a definite sort of time, I suppose, our program is needing to finish in. I did actually look it up beforehand, and there's nothing, the documentation is going to explain it a lot better than me, but it says here, call this function when you've set needs indefinite execution to true to indicate that the indefinite period of code execution has ended. We never do that explicitly. Maybe it's done implicitly when we're using some of these language features like await and asynchronous function calls. But if we remove this, we're going to get an error. So I'm just going to put it back in. It's kind of cool. I didn't know you could open up this here. This is just my playground. It's just got 2 folders in it. That's quite cool. And the program, it's already run itself. We're just going to run it again. But you can see that I think there's an extra There's an extra bracket there. So you can see here that the number of transactions, that's all I'm going to show. I'm not going to show any of the data about the transactions, but the number is 160. You have to take my word that this is actually correct and there's no duplicates or anything like that. But if we come back to our documentation, our Akahu documentation, and we look at our pagination section here, you'll see that it says currently each page will include a maximum number of 100 transactions. However, this may change in the future without notice. So if we don't pass, if we don't use that cursor to get our next page or next response of transactions, then we're only going to get 100 transactions. And I have verified this, and that is the case. So this is just one way around it. This is just sort of a Swift implementation. To be really honest, the TypeScript code that they have here is probably like the best example to understand. It's the most simple. But if you wanted something a bit more in-depth and targeted towards Swift as a programming language, I hope this video has offered some insight in that sense. Or maybe even just to do with sort of the concepts, the ideas behind how you pass in this cursor and how you do that recursively. I hope that's been sort of clear enough. If it hasn't, I encourage you to sort of copy some of this code and try it yourself and sort of see what you can learn from it. That's really important. And if you've got any feedback for me, leave it in the comments below. And if there's anything you want me to sort of explore or try and explain that is related to the Akahu API, I'm trying to learn a lot about it, just in preparation for the Swift Student Challenge. So I'm really keen and open to sort of any learning anything about it, really. And yeah, I hope you all have a great evening or morning whenever you decide to watch it. Maybe it's lunchtime. And we'll see you in the next video.